Okay. Recording now. I'm going to log off my other account and go here. All right. So what we're doing today is we are going to, I didn't think we really needed to do notes today because we are going to just kind of wrap up the periodic table. And the things that we need to wrap up are pretty quick and simple. So I didn't think it was worth going through the hassle of submitting notes. So please, 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 please make sure you're paying attention. And you can ask questions if need to. So just please make sure you're paying attention. And there will be an exit ticket, excuse me, at the end of this that we'll go through and you'll need to submit. And we'll probably finish a little early today, just so you know. All right, so on the periodic table. Well, first of all, if you just got here, I'm going to post the link to the Nearpod another time. Make sure you log on to Nearpod and join because there's going to be an exit ticket you're going to be doing on there at the end. All right, so periodic table. So we talked yesterday about the different types of family, or that was Monday. Let's say Thursday. All my days are blending together. We talked, I think, Tuesday about the different families on the periodic table: the alkali metals, the alkali earth metals, halogens. You got the transition metals, noble gases, and then there's couple families in between. So those are what we're talking about. But now I want you to look at the overall properties of these metals and nonmetals and metalloids. So if you look at the periodic table, a broader classification of this stuff are the metals, nonmetals, and the metalloids. Metals are in pink, so those are exactly what you think of when you think of metals. They are tough. All right, we're going to go over what some more of those properties are. The metalloids are also called semi-metals. I'm going to call them semi-metals because the name makes sense. If you are a semi-pro, you are partially a professional. A semi-metal is a partial metal. It's part of a little bit of metal. And then you got the non-metals, which is pretty obvious. They're things that aren't metal. Okay, so that's pretty obvious. And then if you notice, the table is pretty much divided into those three categories. The only weird one is hydrogen up there in the left corner. And we'll talk about why hydrogen's still on the left side of the table, but is the only non-metal on the left side of the table too. Okay, so just for practice, let's go ahead and color this in. Okay, so go ahead and color this table in based on those three categories, just to show me you understand where the breakups are. So you can go ahead. Let's see. The colors don't matter to me so much. All right, as long as you just kind of get them right. So let's do blue for metals. Yeah, I can do a highlighter. Make it easier. And again, this is an art class, so that's fine. If you have squiggly lines like I do, if you need reference, check up here. All right, if you click the top left corner, I posted a picture. All right, so go ahead and let's draw this in. All right, so in addition to the metals, nonmetals, and metalloids, I'm going to also cover, like I told you, I'm going to talk about this hydrogen up here, why it's on the left side of the periodic table. Even though it's a nonmetal and should be over there, there's a reason. And then also we're going to talk about the lanthanides and actinides. They're not really that special. If you see that they're supposed to be inserted where the 1 star and the 2 stars are. So technically, if you wanted to draw this out, this periodic table would be like really long. But in order to fit this periodic table on one piece of paper that's normal sized, they break the table up like this. So The lanthanides would be in this row here. The actinides would be in this row here. They don't really have a lot of uses, and they're kind of strange, but just want to talk about them nonetheless. I'm going to go like this. All right, so you should be coloring in your periodic table too. Like this, and when you're done, hit submit. Also, the lanthanides and actinides are a lot of the weird ones where you get some strange names from stuff you wouldn't ever think is part of the periodic table. If you were to hear someone say, "Oh, we use californium," you bet you made that up. Another one is americanium. All right, America. All right, we discovered that element. So a lot of times you'll see these weird names in things that the people that discovered it, they get to name it. So if you discovered an element, you can name it after you. You can name it after your dog. You can name it after anything. With thorium, one interesting thing about the periodic table, there is only one letter in the alphabet that's not used on the periodic table. All right. All right, and that letter is letter J. J is not anywhere in the periodic table, capital or lowercase.
What is the code to get in?
The code to get in is FXGRS. FXGRS. All right, so J is the only one that's not on here. They use every other letter in the alphabet. I'm not sure why J is not listed, but it's not. All right. So nonmetals are oftentimes gases. So when you hear the term nonmetal, just remember that it's mostly talking about gases, but there are some things like carbon. If you're using a pencil right now, or if you used a pencil today, tomorrow, sometime in your life, a pencil is mostly made of carbon. Carbon is a solid, so you can hold it, it's solid, but it's not a gas, obviously. So carbon is a non-metal, but even though it's a solid, it's not a metal. So you should be like this. But other than that, like phosphorus is a powder, sulfur can be a solid, but the rest of these are liquids are non-metals. There's actually only one liquid, and it's bromine, and it's talking about at room temperature. Room temperature is 72 degrees. It's what the temperature is, I think, right now. At this temperature, if it is a solid, it's in the blue. If it's a gas or a non-solid, then it's in the green. And the metalloids are somewhere in between. We'll talk about that in a second. All right, so go ahead and hit submit. All right, I'm done, so you should be close to there too. All right, looking pretty good. Okay. All right, so metals are up first. A lot of these things you know already, but this will be part of our end of the week assessment. So what I mentioned I may have mentioned this earlier in the week. At the end of the week, you'll have an end of the week assessment just to kind of see how you did. If you're understanding everything, it will count for your actual grade. So just kind of make sure you're understanding what we talked about today, because
Can you
there's
go
things
back
on
to
there
the
for today.
periodic table because I ain't submit mine.
Okay. All right, did you get it?
You go ahead now.
All right. All right, so like I mentioned, metals are important. You're gonna need to know these properties because it'll ask you you might see a question that says, like, based on these elements, which one's the best conductor of electricity, or which one's most likely to be bendable. This is why you need to know that. So the metals, all right, they are great conductors of electricity. That's why inside wires you see copper that's kind of like a light shiny brown. Copper is inside of almost all wires because it's the best at conducting electricity. All right, inside that it's covered in plastic so that you can hold the wire in your hand and not get electrocuted. But inside there is copper. It's very good at conducting electricity and heat. If you look on those infomercials you see, and you have like the all copper pans, you know, like those copper conducts heat very well too. Copper is a metal. So if you look through the metals on the periodic table, you know, you got, you know, iron, great conductor, chromium, tin, all stuff like that. There's a bunch of other metals that you probably have heard of before too. Gold, silver, those are all good conductors of electricity. Dense, they are shiny and dense. Dense means that they are heavy and they have lots of atoms packed together in a small space. So they almost all sink when they're put in water. Metals are malleable, which means they're malleable is a word that means able to be bent. So you can, again, take a piece of copper, bend it in half. You can take aluminum ball, crumple it up, pull it back out again. You can mold gold and silver into jewelry by bending it. So those are properties of metals, that they can do that. You cannot do that with carbon. If you take pencil lead and you bend it, it snaps. All right. It's not shiny, right? And it floats on water. So that's another reason why it's not a metal. They have high melting points, meaning you have to heat them up a lot in order for them to melt into a liquid. So they're all solid. You have to add a lot of heat to them in order to turn them into a liquid. All right, I'm going to go back to copper. You can't really melt copper on a stove. Okay. I don't know if you guys were with me when I did this example in class. Most of the pennies today are not made out of copper. So copper is actually expensive now, and the price of it's gone up. So in 1985, I think 85, on the penny, if you look, it says 1985 or above. It's not made out of copper anymore. It's made out of a metal called zinc. So if you scratch the penny on the sidewalk, you'll see underneath it there's a shiny silver metal inside. So they coat it in copper, which is a lot cheaper than actually making it out of solid copper. So if you heat up a penny on a stove, it'll actually melt and it'll kind of crumble. But don't do that, because once the metal cools again, then it becomes a solid metal and it could mess up your stove. But if you did it in like a pan or something like that, you'd be able to see what I'm talking about, because you can melt pennies, because the metal inside has a different property than the metal on the outside. But if you can find an old penny and you stick that thing on the stove, it'll get crazy hot. It won't melt at all. All right, I'm just going to go to the other end of the spectrum, just so it's quick and easy. Non-metals are exactly what it sounds like. They're not metal. Anything that's not metal. They are bad conductors of heat and electricity. That's why electricity can't jump from your outlet to you and electrocute you. Now, there are certain circumstances where that can happen, but there's got to be a lot of stuff around it that's changing. Like, you have to have a very strong electrical force, and it's got to be moving in order to jump from one place to another. So it's possible, but it's very hard to do and requires a lot of energy, so it's why it's not practical. Also, they don't bend very well, all right? So gas that's in the room right now, oxygen, you can't grab it and bend it. It just falls out of the way. Same with like any liquids. They don't bend very well. They're dull. So if you look, again, think about pencil lead. That's almost pure carbon. If you look at it, it's not shiny. It's like a flat black, kind of color. Those aren't shiny. They don't conduct heat very well, all right, which is why it's hard to heat up a room because you have to heat air particles that don't transfer heat very well. Heat is transferred by the touching of particles. We're going to go over that later. And if the particles are farther apart, like they are in the air, it's hard for them to transfer that energy from one place to another. So that's why air molecules are not good at transferring heat. They're not good conductors of electricity or heat. Many nonmetals are gases. So there's only a few that are solids, but not metals too. Lastly, semimetals. This is kind of a tricky one because they're partially metals. So they have properties of metals and non-metals. So for example, some of them can be shiny, others can be dull. Some of them can conduct electricity, some of them can't. Or they change their properties as you change the temperature. So there are semi-metals like silicon where if you ever notice that your phone stops working when it gets too hot, it's because silicon is a metal when you increase its temperature, it stops conducting electricity. So if you look on the slide I have there, you can see that there's a circuit board, all right? That green stuff is silicon. It's basically like channels and highways that the electrons travel down in order to make your phone function. So the problem is when you heat that up too much, it stops conducting electricity. It turns into a non-metal. So that's why your phone stops working when it gets too hot, is the silicon inside your phone stops conducting electricity and your phone stops understanding what to do. So, but silicon is good because it's very readily available, it's cheap, and it's easy to put into phones. So that's why it's a good semi-metal. So sometimes you want them to conduct electricity, sometimes you don't. So this kind of diagonal group on the periodic table, there's only 7 of them. They're kind of like, if you think about the periodic tables transitioning from metals to partially metals, the diagonal, all the way to non-metals is the next part. So just think about these as being sort of metals and sort of not metals. Okay, short quiz, just to kind of see how we're doing. 2 questions. So first, what is the best conductor of heat or electricity? And then in the second question, I give you a few different elements, and I want you to tell me which one is the worst. So which one is the best out of those 3? And then on the next slide, I'm going to give you 3 different elements, and you have to tell me which one's the worst conductor. And you guys, like 2 minutes, 1 minute per question, which is way too much time, but just make sure everyone gets it in. All right, please make sure you're reading the question carefully. I have a few people that have answered the same thing on both questions. So how could something be the best conductor and the worst? Think about that. Your two questions should not be the same thing. They cannot both, one says the best, one says the worst. Question one is asking which is the best? Is it metals, semi-metals, or non-metals? And then this next question is, I give you three different elements. All right, you need to figure out, are they metals, non-metals, or semi-metals? And then answer the question. Okay, so make sure you're thinking before you answer. All right. All right, so here are the answers. Which is the best conductor? Best is key right there. All right,
Only got one right.
Conductor of electricity. Metals. Metals are the best conductor of heat and electricity. Their molecules or their atoms are very, very close together, which allows them to easily transfer heat, energy, or electricity. Which is the worst? All right, so we have a metal is chromium. Silicon is a non-metal. I'm sorry, a semi-metal, or a metalloid. And then chlorine is a non-metal. Non-metals are bad at transferring heat and electricity, so the worst conductor would have been chlorine. Okay? So what I was saying was you shouldn't answer semi-metals and then silicon, because you're saying, if I understand if you chose it on the first one, but then you can't go ahead and say it's the worst on the second one if you already said it's the best. Okay? So elements that fall in that little diagonal piece, those are semi-metals. All right, so to wrap up real quick, all right, what's up with hydrogen? So hydrogen, it sits at the top of group 1. Group 1 is a bunch of metals. All right, can someone post in the chat what group 1 is called real quick? What is group 1
Alkali
called?
metals.
Very good. All right, alkali metals. Group 1. So what I'm saying is that hydrogen is still an alkali metal, but hydrogen's gas. So how can it be a metal? So what scientists have found is if you take hydrogen, all right, so people much smarter than me have figured out, you know, these things, and they're in their labs for days, and they understand like these things more than they understand themselves. So when they test a lot of these elements, they cool them down to see if when they change phase. So when hydrogen is cooled enough, it turns into a solid. So it's not liquid, it goes to a solid. So when it's a solid hydrogen, it acts like all the alkali metals. So at its core, hydrogen acts like an alkali metal when it's a solid. It's like a squishy metal. It's very, very reactive. It has one valence electron, so that's why it's over there. All right, even though hydrogen at room temperature, all the elements on the periodic table, you have to assume that they're talking about it at room temperature, which is how warm you are about right now. I know some of you guys probably are in air conditioning, or maybe not, so it might be a little colder, a little warmer, but that's just about room temperature. So at room temperature is what we're talking about with every element on the periodic table, and at room temperature, hydrogen is definitely a gas. But if you cool hydrogen down enough, it shows properties of an alkali metal. and it only has one valence electron, and it needs 2 to fill up its shell. So that's why it has all the other properties of an alkaline metal, but it's on the left side of the table, even though it's a non-metal. So it's the one exception on the table. All right, and then I just wanted to quickly touch on the the actinides and lanthanides. We don't really talk about them much because we don't really do much with them. They're mostly man-made. You can make elements in a lab by smashing the protons together. So I know this sounds really silly, but if you take one atom that say has 6 protons, and then you have another atom that also has 6, so you take 2 carbon atoms and you smash them together, you can make magnesium, which has 12. So something we didn't get to this year in physical science is the formation of stars. Inside of a star, it takes a hydrogen atom and a hydrogen atom. Each has 1 proton. All right. There's so much heat and pressure that those nucleuses fuse, and then it makes a atom that has 2 protons in its nucleus. So then it has 2, which is helium. So helium is another element. So that's how they fuse different elements together. They just smash them together. So anyways, you can do that in the lab, and that's how they made up most of them down here. So these ones down here are mostly man-made. So they actually, and this whole group would slide right in the middle there. So we don't talk about them much because we don't have much of a use for them. They're mostly radioactive and dangerous, and they don't occur naturally. My son is making a lot of noise. All right. All right, so that's kind of going to wrap it up for today. The exit ticket is on the next slide, so it'll take you to the exit ticket in a second once I switch slides. So what you're going to do is you're going to follow the link, sign in to Quizlet. You can use Google to sign in. You're going to have to make a screen name, so just make it your name with like your birthday at the end. Just make it simple. So you're going to follow the link. It's a link to a vocabulary test. What I mean by test is it just has a bunch of multiple choice and matching just to make sure you understand the topics and vocabulary we've covered this week. So when you're finished, take a screenshot. You must get over 70%. All right? Because there's no real point in just clicking through it, getting a 40% and pretending like you know it. Just make sure you understand it. So then on what you're going to do is you're going to take that screenshot and submit it on Schoology where it says Quizlet exit ticket. So in the week 2 folder, you'll see a assignment that says Quizlet exit ticket. And it's going to be blank. It'll allow you to add a submission. When you add a submission, you attach the picture and send it in, and that's it. As long as you get, as long as you get over 70%, you'll get 100% on the assignment. So if you get a 80%, I'll see that, and then you'll get full points on the assignment. Brian, you had a question?
What I was going to say is we can take it as many times as you want.
Yes.
Okay.
Yeah. So just make sure that you take a screenshot of it and submit the screenshot. You have to get over 70%, so you can try it as many times as you want. Feel free to use you can pull up your notes if you want to help you out. It's meant to be helpful for you. Okay. Any questions before I switch over to the next slide? Okay. All right, your test should look, when you get in there, it should look something like this. Everyone's questions will be different, so yours might be in a different order. Then what I want you to do is take a screenshot of your score and submit that. So we have the rest of the time to do that. Once you do that, we're going to be done for today.